big family of functions that you guys are going to see in Calculus 1 is rational functions like this one. Basically, it's a function that is polynomial divided by polynomial. And one of the questions, the very first one, is actually, what is the domain of such a function? Now remember, in mathematics, when we have fractions, the denominator cannot be 0. Therefore, the only restriction that we have here is make sure the denominator is 0. So in order to figure this one out, what do? Is we actually set the denominator equals 0. So let's focus on this part. You have x cubed minus 3x squared plus 2x equals 0. So we'll solve this equation and we will discard the numbers that we get out of this. All right, so how do we solve this one? This is not an easy equation. It's a third degree. We have to do it with factoring. As you can see, x is a common factor in all three terms, so I will take it out and have x squared minus 3x plus 2 equal to 0. And I can continue on, because this one can be broken down further using a trinomial. We're looking for two numbers that add up to 2 and add up to minus 3 and multiply to 2. And of course, these numbers are minus 1 and minus 2, right? Minus 1 plus minus 2 gives you minus 3. Minus 1 times minus 2 gives you plus 2. So this can broken down further as x times x minus 1 times x minus 2. All right? Becomes this big product. Now remember, when we have a product equal to 0, it means that at least one of these terms is going to be 0. So basically, this very long equation turns into three smaller equations. Either x is 0, or x minus 1 is 0, or x minus 2 is 0. That's really the benefit of breaking it down like that. You're breaking down to simpler equations. And now, of course, this gives you x equals 0, or x equals 1, or x equals 2. So what we really need to do is we need to remove these guys from the domain of my function. So in order to answer the question, you say the domain of the function is all numbers except 0, 1, and 2. Yeah, but that's not the way that we present things here. There is a mathematical notation using the intervals. So we need to somehow skip over these numbers as we're considering the whole interval of numbers, from minus infinity to plus infinity. And the way to do that is as follows. It's a nifty trick. We start from minus infinity, and we go to the first number, 0. And if we put an open parenthesis, remember that means exclude 0. Then you put a union to say continue, and start again from 0, but again with an open parenthesis. And what happened over there is you jumped over 0, basically. And you stop at 1. You continue from 1 to 2. And you go from 2 to plus infinity. And this is the interval notation that jumps over, as you can see, 0, 1, and 2. And that's your final answer. That's the domain of the fraction. And as you can see, we didn't really use the enumerator. The enumerator can take whatever values it wants. It's just that when you have fractions, the denominator must not be 0.